Hi everyone, I'm going to go through task 445, histograms 4. It's a very tricky Hegarty task. A lot of people have been very successful on the first three tasks and then have found this task quite a bit harder. So what I'm going to do is I'm going to go through it. I've loaded up the quiz. I'm going to take screenshots, put them into PowerPoint, annotate it, and then put the answer in and explain my thought process as we go. So your questions might be slightly different to mine. The working out and how you actually do this is going to be the same, just with different numbers and different questions. Okay, so with our first one, this is question 1. I'm just going to take a quick screenshot of the question and put it into PowerPoint, and then hide that, and there we go. I should now be able to draw on this. Right. The histogram shows the ages of all the workers in a London office. So we have workers that are 20 up to 65, what it certainly looks like, and the class widths are not all the same. We have one here that goes from 20 to 25, 25 to 30, 30 up to 40, 40 up to 55, so this must be 55 here, and then the oldest is 65 there. And it says there are 24 people in the 40 to 45 age range. So this is this box here. The area of it is 24. We know that because the frequency is the area. We also know how wide it is. It's 15 across. So that's the information that we actually know. The question says work out the total number of people in the office. So that means we're going to need to find all of these areas. We already have this one, of course. And then we're going to have to add them all up because the total frequency will be the total area. Because for a histogram, frequency and area are the same thing. So in order to work these out, notice I know how wide they all are. This one is 5 wide, this one is 5 wide, 10 wide, and the last one is also 10 wide. The tricky part is knowing how tall each of the rectangles are. And so we have to use the information here from this rectangle to work that out. So what I'm going to do is I'm going to load up the calculator and I'm going to do 24 divided by 15. And then as a decimal, that's 1.6. So what that means is that this rectangle here is 1.6 tall. So I can't really draw that, but you get the idea. Let me just use my mouse. So this is 1.6 tall. Which means if you go across, if you follow it across, and this is why I appreciate this is really quite a tricky task because you have to look at the computer screen to do this. You could, of course, copy and paste it and print it out, or you could copy and paste it and do a similar thing to what I'm doing. But what you've got on the side here is you've got that this must be 1.6 here. Now we've got the frequency density at the side. And so what you have to do is you have to work out what this is going up in. So let's just see, is it going, just by looking, I'm just going to guess because of how tall it is and the fact it says 1.6. It looks to me like it might go 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0. So if I put 1.0 here, I think this is going to be right if you keep going. 1.1, 1.2, 1.3, 1.4, 1.5, 1.6. So each of the little squares, which is very hard to see, each of those is worth 0.1 on the frequency density, which means this is 2.0 here, and that goes all the way up. The tallest bar looks to me, so that's 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, and 2.8. So that there is 2.8. That's how tall this one is. And then after that, you just kind of have to fill in the areas. You go straight to that. So let me load the calculator up again. What's the first one? We have got a width of 5. So this is the 20 to 25 one I'm talking about. It's got a width of 5 and a height of 2. So, okay, so 5 times 2 is obviously 10. Don't need the calculator for that one. So this one here has an area of 10. This one here is 5 wide, but is 2.8 tall. And remember, I worked out that 2.8 because I first of all established that this was 1.6, and then I worked out what the scale was. Now, the scale wasn't too complicated, actually. It was just going up in 0.1s, but it was quite tricky to see. So I need to do 2.8 times 5. So this one here is 14. The area is 14, done width times height, but that means it's a frequency of 14 for that bar. Now this one here, that is one little square less than the 1.6. So that must mean it has a height of 1.5. So I'll do 1.5 times 10. Now I don't need a calculator for that one. I know that that's just going to be 15. We already know this one is 2.4. To be clear, it's because it's 15 times 1.6. But we actually got told that it was 24 in the first place. And that is where the number 1.6 actually came from. So we figured that out because we know it's 15 wide and we know the area has to be 24. Right, and then lastly, it is 10 times whatever this is. So if that's 1, 1.1, 1.2. So it is 1.2 tall and 10 wide. So that is an area of 12. There must be 12 people in that group. So then all I do is do 10, add 14, add 15, add 24, add 12, 75, and then I hope I haven't made a mistake. What am I going to do? I'm going to type in 75. Wants the total number of people. So there you go. First one done. Let's press next question and copy and paste that into PowerPoint. Right, so that's now in PowerPoint. Question 2. So the histogram shows the ages of all the workers in a London office. It says there are 24 people in the 40 to 55 age range. So that very much looks like there's 40 because it's halfway between 30 and 50. There's the 55. And it's 24 people in here. And again, it says work out the total number of people in the office. It's very similar to before then. We need to work out how tall that is. So I'm going to do 24 divided by 15 again. It's not always going to be divided by 15, by the way. It just so happens that twice in a row, that was what the width was. So this time that height is 1.6. That's the same as last time, isn't it? In fact, is that the same? That's the same question. Although, okay, it's the same beginning of the question, but notice the histogram is actually different, isn't it? So it's actually not the same question. We're probably going to get a different answer. But so far, the working is the same, right? It was 24 divided by 15. So this is a height of 1.6 again. Now I'll just say it's basically because it's Hegarty maths. They might not always have a lot of variety in their question. I hope you're happy with what the working is. It would depend on how wide it was and then what the number was. And you want to work out how tall it is. And then from that you work out the scale, and then you can work out all of the areas. So that's the order it goes in. So we know that this here is 1.6 because it's literally 1.6, which means it looks to me like it must be going up, what, 0.4, 0.8, 1.2, 1.6. It's going up in 0.4s on the main scale, so 0.4, 0.8. So 0.8 is halfway between 0 and 1.6, and that's halfway, so that's one way you could have spotted that. I just will pause and remind you, yes, this is quite a hard task, so don't worry too much about it. It's definitely a lot harder than tasks 1 to 3. So this main scale is going up in 0.4s. And now we just have to figure out what all of these are. So this has a width of 5 and a height of, so that goes 2.8, 2.9, 3, 3.1, 3.2. So each of the little ones is again 0.1. So this is 3.0, or just 3, times 5. So this one without a calculator, this must be 15. So I'll say that again, 5 wide, 3 tall, so the area is 15, which, because it's a histogram, is the frequency. Next one, 2.4, it's exactly on the 2.4 line, times 5. So on the calculator, I'll do 2.4 times 5, which is 12. Next one, 10 times 2.6 is 26. We've already got the 24, and then this one is 10 times 2.3, which is 23. So on the calculator then, I'm doing 15, add 12, add 26, add 24, add 23. I get a different answer to before because it is a different question. Let's bring that screen back and type in 100. Number 3. So let's take a screenshot of that. I've now got it in PowerPoint. Let's hide that window. And here we are. So we've got question 3 here. So the histogram shows the time in seconds it took members at a swimming club to swim the length of the pool. So there was some very fast people down here and some slower people up here. So that's the idea of this histogram. Given that 5 people swam it in 20 seconds or less, so it means this area here is 5. Estimate the fraction of members who took longer than 42. So 42, it's actually a little bit into this. Now I'm not going to be able to easily draw that on account of I'm not very good at using this pen. So with my mouse, I'm actually going to kind of cut it here. Put a little arrow to there and say back with this pen, that's where 42 is. And what you're looking for is you want this area. So apologies, this will take a little bit of time to fill this in. But we want this area here. We want the total area, including into the next box, because all the people in the next box took longer than 42 seconds as well, didn't they? In fact, we can say those people all took longer than 60 seconds because of the box that they're in. We want this total area right? That's going to be the number of people who took longer than 42 seconds. Let me just hide the calculator as well. There you go. So this bit here is where 42 is, first of all, on the time axis, right? We want to look at 42 seconds. And everyone to the right of it took longer than 42 seconds, right? Someone could have taken 50 or 60 or 70 or 80 seconds. And we're looking for an area because it's a histogram. The area is the frequency, which is how many. So we need to work this area out. And then we're going to have that out of the total area because it's a fraction of members who took longer than 42 seconds. So this is only part of the answer. We want this number out of the total area. And then we have to bring it all the way back to the beginning. We need to work out what the scale is on the frequency density in order to work out each of these areas. So I'm going to show you how to do this now. So first of all, this one here is 5 wide because it's going from 15 to 20. How tall is it? Well, it has to be 1 tall, because if it wasn't 1 tall, it doesn't have an area of 5, which means this one is height of 2. And if, therefore, again, all the little squares must go up in 0.1s. You've got 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then you get to 1.0. So let's just check. They're all quite easy to see how tall they are, except this last one. This last one looks like it's 1, 2, 3, 4, 5, 6. It's 0.6 tall. So I might just make a little note of this, that this last box has a frequency density number, a height of 0.6. Okay. Now I'll choose a different color and start filling in some of these. So this is a distance of 10 along the bottom and a height of 2, so that's 20. This one is a distance of 10 along the bottom and a height of 1, so that's just 10. Let's do the full box. So this is a distance of 20 and a height of 1. So this is a total of 20. And then this one, this box here, is a distance of 20 along the bottom and a height of 0.6. So if I bring the calculator back up, I'm going to be doing 20 along the bottom times 0.6 tall. Of course, that's just 12. So this is 12 in total, which means, I was trying to get rid of the calculator and I brought the other screen back. There's the calculator gone. I can work out actually how many people there are altogether. So I need to do 5 add 20, add 10, add 20, add 12. So I'm adding up all of the areas. So there are 67 people in total, or 67 swimmers in total, if you want to be more specific. So 67 people in total. How many of them did 42 seconds or more? Well, we've got these 12 people, and we need to then work out this extra part here, which goes from 42 up to 60. So 42 up to 60, it's a distance of 18 along the bottom, still a height of 1. So this part here, if I just click back into here, this part here where the mouse cursor is, that's actually 18 people. So there's 18 people plus 12 people. This red area with the horizontal lines, that's 18 people plus 12 people. That's 30 people. 18 add 12. So we've got 30 people who took longer than 42 seconds. Let me just get rid of the calculator again so you can see that writing. So this total area, we've actually figured it out, that was 30. So this is 30 out of 67. It's 30 people who took longer than 42 seconds out of 67. So assuming I haven't made a silly mistake, I should be able to go back onto here, bring up the on-screen keyboard and go 30 over 67. Right, next question, last one. Now if you think you've now seen enough and you want to give this a go yourself, please don't feel free to, you know, leave a like now and leave the video. Otherwise, I'm going to answer this last question. So I'll take a screenshot like I did before. Last question. I'll try to answer it quickly as well, so I will say less about it and I'll just try to do it. Let's minimize that, get that off the screen. Right, here we go. Last question. 10 people swam it in 10 seconds, 20 seconds or less. So that's these people here. So this has an area of 10 because it's the 20 seconds or less, 10 people. That is a distance of 5, which means this is a height of 2, which makes that 1. It means each of the little squares is 0.1, which means this has a height of 1.2. This has a height of 1, 2, oh, it's very hard to see. 1, 2, 3, 4, 5. It looks like. Let's see if I kept counting would I get. So 6, 7, 8, 9, 10. Yeah, so this has a height of 0.5. And this one that has a height of 0.6. I can see that much more clearly. Height of 0.6, which means let's just fill in the frequencies. So I've got 5 times 2 is 10, 10 times 2 is 20, 10 times 1.2 is 12, 20 times a half, that's a half of 20, which is 10, and 20 times 0.6 is 2 times 6 is 12. So 10 add 20 is 30, 42, 52, 64. So there are 64 people in total. So 64 swimmers total. Let's just double check. So 24, 34, 54, 64. Yep. And we want to estimate the fraction of members who took longer than 42 seconds. So again, it's 42 seconds. So they don't have a lot of variety in their questions, it would seem, or maybe I've just been unlucky, but it certainly seems to be exactly the same question. So again, I'm going to just go along to 42 here. This is a distance now of 18 along instead of 20 along, because what I actually want is I want this area and this area. Right, because all the area that I've coloured in there, that's the swimmers who took longer than 42 seconds. So I already know that this bit's 12. Right, I coloured over that actually, you can kind of still see it. It says 12 there. Now this isn't quite 10 anymore, because there's some swimmers who took between 40 and 42 seconds. So let's actually work out how many it is now. If it's 18 along and 0.5 up, if you do 18 times 0.5, you get 9. So altogether, it's 9 plus 12, which is 21, who took longer than 42 seconds. Which means my answer is 21 out of 64. Right, I hope that this has been helpful. I appreciate it is hard to see. It is not the easiest task that I could have set. However, if you do really have a good go at this and persevere, you will feel very rewarded at the end. That will have been an excellent effort. I really believe that if you listen to what I've said here and really give it a good go, then you will be able to do this. Obviously, I appreciate it is a little bit frustrating because you have to do it on the screen and stuff like that. Anyway, best of luck. Any further questions, please just send a comment or something like that. I will see you next time.